now it's extracting more and more information. A whole community has formed, but we have already heard about this. So here again, there's a list of limitations of Wikipedia. Like the thing is that Wikipedia contains a lot of information, but it's not readily accessible. So if I want to answer these questions, what have Innsbruck and Leipzig in common? You need, okay, in this case you need to look at the 2 pages, right? So you need to look at Innsbruck and Leipzig. This is probably doable, you might answer this. But if you want to know who are the majors of Central European towns elevated more than 10,000 meters, then you would have to look at a lot of Wikipedia pages actually. And do a manual research. I think this is a lot of people from the social sciences, they are doing a lot of research like this, like looking at a lot of material and collecting certain pieces of information just to make a list of something. So this is basically. So here is an overview, in-depth overview of what we are gathering in Wikipedia. Okay, so this may not view goes so well, but there's the title information, then geo-coordinates, the abstract, the language links on this side, the information in the info box, including the images in the page, like links to the images as well. And then these are the Wikipedia categories and links to other pages. So these are links to other language versions, other Wikipedia pages, to the web, and then redirects and disaggregation information.
Am I correct that the info box is actually the only structured part of a Wikipedia page?
No, there's a lot of structure. I think you wouldn't even call this structured, right? So yeah, okay, can go on. Let's look at the image page. So you see this part is structured, the geo-coordinates is structured, this is structured, the language links are structured. Basically the origin of DBpedia is this part here. And if you look at the info boxes, they are in a special, this is what the Wikipedia editors are editing. So you could argue that this is kind of like still user-friendly because there are 500,000 people editing this format, right? But this is also not structured, right? Because here, okay, in this case here, this is structured maybe. It's a key value pair. But this part here is not structured anymore, the image caption. Because there's text and also wiki syntax. So it's always a mixture. So you cannot really say that which part is structured or not, because this wiki syntax actually is not well defined. It is defined by the part, there's no definition of this, no formal definition. It is defined by the PHP program that renders it into HTML. So this is it's not really a scientific, well-defined language. And the parser also has some relaxations, so there are some exceptions which it can cope with. So you wouldn't you wouldn't call this structured in the sense of a database. So this information is extracted by the DBpedia information extraction framework, which started in 2007. We moved from SourceForge to GitHub, and it was initially written in PHP. But now it was fully rewritten in Scala and Java. And nowadays it has around 40 contributors. And you can click on this link to get a detailed developer's overview. And one interesting part is because it is has a parser for this media wiki syntax, you can potentially adapt it to other media wikis very easily. So this means corporate wikis, organizational wikis, I don't know, also other wikis on the web, like there's travel wiki, how-to wiki. We worked on a conversion of Wiktionary, which is a special case because it has a very complicated structure. And here's an overview of the software. So basically on the left side you have the data sources, which is in this case Wikipedia, and the ontology mappings. I'll come later to this.
Do you know what the acronym means in Dutch?
Yeah, can you remember?
What?
The acronym thief.
What does it
The
mean?
Dutch word for thief.
Ah, really?
Yeah.
Okay.
Well, exactly what you do, you steal the data. So it's a good acronym.
Yeah. So this is the thieving pipeline, yeah? Yeah, so there are different input sources. There's a dump source and an API source. So the dump, Wikipedia is actually a great project. They provide dumps each month or so of each media wiki installation they have, and then this can be analyzed, which runs about a week. Or if you want to analyze the whole dump and convert it to Wikipedia, it needs a week of processing time. The English one, the English version. But there's also API source which can get live updates, letter updates. And you go through a wiki parser, and then you have different extraction components, like which extract label and geo coordinates, and then there's mapping-based extraction as refinement rules to improve the extraction. So in general, if you ever do an extraction, if you ever have an extraction job, let's say you have some kind of data source, want to convert it to something else, you have basically three ways to do this. You can do it completely manual. If you have a lot of users like Wikipedia, this is feasible, right? Or if you have 100 librarians or so, and they kind of like want to do the work manually, that's fine. You can do it fully automatically if you have a small team of computer scientists, developers who, let's say you have a two-year project and 3 developers, and they can create automatic methods to extract the data. And if you have neither, you can do a mapping-based approach, which kind of like you have a few people or a small group of people who have relatively good know-how, and they can write extraction rules which help to analyze the data. So this is, in this case, it's DBpedia. This is the middle way. Okay, I already said this. Okay, the extractors are the most interesting thing. So first the wiki page is analyzed into an abstract syntax tree, like a memory model, and this is further transformed by the extractors. So here's a straightforward example of how the triples are generated. On the top left, there's the infobox syntax, which is actually, this is also a very old principle. So you have entity. It's called entity attribute value. So you have an entity, in this case, Busan Metropolitan City, which is the entity you talk about, and this entity has attributes and values. So it's actually RDF is nothing new. The use of URIs is new, but this entity attribute value thing is quite an old concept. Yeah. And it's very easy to understand, right? So you have properties and values, and if you look at the transformation, it's also very straightforward. Like these are in Wikipedia, these are links. Let's say region should be here somewhere. Yeah, region is here, and then this becomes a link in RDF as well. So the transformation is quite straightforward. Here we see something which shows the semantic heterogeneity in DB in Wikipedia, and why we need these extraction rules. So you have two persons here, which are of a different type, so they have different info boxes, and the semantics of this property, this key value pair, is different, because in the left side you also have the birth name. So he was born as George Andrew Romeo, and here you don't have this. I think this is cut off. So you could have different semantics. For example, born in this case could be place, date, or the name. And the info boxes are all different. I don't know why it's cut off. Here's. So you need to actually transform it in different ways, right? So in the top part, where Björk is, you have the date and the place. And here for Brown, this is separated, so you have the date and the place separately. And here also the property is just spelled differently, so that's a syntactic heterogeneity, right? Just a different name, but for a computer, this is of course a string more. So one of these extractors is the raw info box extractor, which does a direct translation without any intelligence, right? But this doesn't produce. This produces a high coverage of data, but not high quality. And then you have this mapping-based info box extractor, where we try to improve the semantics, and this is crowdsourced. So you can go to DBpedia and edit these mappings, right? So they're born into birthplace, for example. And this has definitely shown to provide a big boost for precision and recall. And here also you see the multilingual problem. These mappings, they allow to query across the different language versions of DBpedia and Wikipedia, because these rules unify this. For example, this rule here, the property mapping for this property here, for this info box, this is a Greek info box of book. It says to map to the English class book, or the English written class book. Of course, the concept book is the same in Greek and English. And then you also map this string to the ontology property author. So it's a simple transformational mapping. And then you have the effect that the data extracted from the Greek Wikipedia looks the same as for the English Wikipedia. Any questions so far?
One question. When you, on your slide before, when you showed the different type of info box, no, it was just the one after, when you say, like, for example, sometimes you have birthplace with an underscore in between and sometimes not.
Yeah.
I thought when you entered this kind of information in Wikipedia, then you had a kind of, not validation, but so that means when you enter this information in the wiki, you don't check. There is no check.
No, there's no check.
Okay. So there is no enforcement of rules when you edit a page, in fact.
No, there's nothing.
Okay.
So basically, I mean, we can maybe try. Let's look at the root of the problem. So this is the template definition here, which defines how it's rendered, right? And basically, it's documentation. There is documentation, but very often people just don't read them.
And it's the same in Wiki Commons, for example, when you use the templates for book or the other one is not paintings but artifacts.
I think it should be the same in all, because it's all based on the same software, and the software is not very strict. So there's no. Actually, what happens now is, I think, because we did this with DBpedia, I think, for example, the Greek language version of Wikipedia, they use these mappings to clean up their Wikipedia, right? To improve the errors there. The one problem is the English community is very, they have their own ideas how things should be run. So also we are a little bit behind because we mostly do the dump-based extraction, not the live extraction. So data gets stale very fast, so we cannot give back really good.
And would the development done in Wikidata, would that have an impact on the way people then would enter information in the template? Because I guess this kind of properties like a birthplace, probably they will be defined in Wikidata as well, so I was wondering if then...
I think there is no semantics neither in Wikidata at all.
Yeah. I don't want to speculate, so there is data in Wikidata, I can say that. I don't know. Let's see. Okay. Here are some URI schemes, which is always important. Well, let's say you are planning your own linked data project in the future, then you should think about stability of your URIs. So in this case, of course we adopted the schema of Wikipedia for DBpedia, but there are some problems with this as well. So in the end we used always the language, then dbpedia.org/resource/the article name. So you can do the mapping between Wikipedia and DBpedia with a string replace of the URI. It's very simple. But this also creates a little bit anomalies. Sorry. Because articles are actually renamed. So once you publish a URI, other people link to it. If you then rename the URI, then the link becomes dead. So every time you coin a URI, you have kind of like a little bit of responsibility to make it stable. If you use IDs, the thing is much simpler because you can just make a new ID for something and say put something at the old one that it's invalid or move to somewhere else. So this is then there are two extraction modes. One is dump-based, which normally happens every 3 to 6 months, although we try to increase the frequency. And the other one is the DBpedia live extraction, which I will talk to about in a minute. And these dumps are also downloadable here, downloads.dbpedia.org, and described on the web page. I think these are very, very well documented. And here's the statistic Patrick wanted to show us today, this morning actually. So here's the average hits per day on the Sparkle endpoint, and now at the moment I think 3 million Sparkle queries is quite a lot. If you consider that the Sparkle queries are mapped to SQL, and then the SQL, of course, can do a lot of inner joins. Like join the table, because it's one table with 4 columns, and with Sparkle you join the table with itself. So these can get quite complex, and then answering 3 million requests is quite a lot. Okay. Yeah, you can also see which data sets are loaded at the moment. So, and with this public Sparkle endpoint, you can answer these queries. Here's the example. I'll show more Sparkle queries later if you want to. So this was the question: all soccer players who played as goalkeeper for a club that has a stadium with more than 40,000 seats and who are born in a country with more than 1 million inhabitants. So to answer this, you would kind of like need to jump in between the Wikipedia pages and build the graph manually to make this collection. This query is also quite fast. Needs maybe less than a second.
Less than a second?
Yeah. Yeah, I cannot copy it here. I think it's a screenshot, so I... then we have DBpedia Live, which was, or still is, quite an engineering challenge. So Wikipedia provided us with an update stream, which gives us, every time an article is edited in Wikipedia, we get an updated version. And this happens around 100,000 to 150,000 times per day, which is quite a lot. It means that you have only 0.7 seconds to parse one page, which is really difficult. But in practice, normally editors of Wikipedia, they edit a page, and then they click save, they look at it and see that they made something wrong, and then within 5 minutes, 50% of the pages get re-edited. So if you just wait 5 minutes, then you can increase the performance by 50%. Just skip the. And here, yeah, let's, okay, maybe we look at this, because this was a question. There is a link where you can download all the diffs on a daily. So here, yeah, there have been some problems. Like here, you can get all the triples which were added, like added and deleted during a certain time. So if you go from July 2013, for example, you can get the triples which were added and deleted during that month. Yeah, for each day. Simple update comes. So here's an overview pipeline. One more challenge is also for the DBpedia live extraction. There are actually 3 things that can change. Once it's the articles that can change, or they do change, then it's the software that can change, and then it's also the mappings that can change. And because of this, the live extraction works in a way that it reparses all pages at least once every 2 weeks. So if the software changes or the mapping changes, then old articles are reparsed within 2 weeks. So this means that no page should be older than 2 weeks, actually. Yeah, we have this. I think I'm not going to repeat anything from this morning. Right? Fine, I can show some. Let's look at some applications. This is done by a group from Düsseldorf. They made quite a I'm just showing these. I think you can play around with them later. They are quite good tools.
So what was the URL?
Wait, I'll show you where to find these. But that's probably best. So here there's on our. This is also a wiki page. It's right on the front page, applications, and you have all the applications basically that use DBpedia. And you should just go through the list and look what you need, right? And if you have any applications, I would urge you either to get registered in Wiki, add it here yourself, or send it to the list so somebody can add your tools to this page, right? So they get collected. Yeah, there's actually, okay, there's a lot of applications on that. So actually, this is not maybe not so interesting. Well, okay, let's say it like this.